Hello students, I am Nilanjana Sanyal, an online math tutor from India. Welcome you all to my channel NS Online Math Classes. Our today's topic is the binomial theorem. The binomial theorem expansion will be given in the form of sigma notation and the coefficients will be expressed in the form of NCR. Now, what do we mean by NCR and how do we express the binomial theorem expansion in terms of sigma notation? We will be learning everything in our today's session. So, without any further delay, let us start with our today's session. The binomial theorem. The binomial theorem states that we have learnt about the binomial theorem previously, the binomial expansion, and we had seen that when we are having the binomial expression as a plus b, this is getting raised to the power of n. The binomial expansion will be containing n plus 1 number of terms and the power of a will be starting with n and ending with 0 and the power and decreasing in steps of 1. And the power of b will be starting with 0 and ending with n and increasing in steps of 1. We have seen all these and how to get the coefficients of the terms using the Pascal's triangle. And we have seen the drawbacks of using the Pascal's triangle as well. Therefore, we come to this form of the binomial expansion. This is the sigma notation. Sigma notation is nothing but addition of the terms, of several terms. It is the shorthand notation. Instead of writing all the terms individually, we express all the terms. Obviously, there should be a variable because for different terms, the variable value will be changing and the terms will be getting added. In case you do not know the meaning of sigma notation, I would definitely be asking you to watch one of my previous videos on sigma notation. Actually, that is a series of 4 videos on sigma notation. But I will be giving you the link for the first video on sigma notation in the description area. Okay? And we are seeing the r is the variable whose starting value is 0 and the ending value is n. Since the starting value is 0 and ending value is n, therefore, it is clear that there should be n plus 1 number of terms in the expansion. Okay? And this one is NCR. NCR enclosed within this parenthesis, or you may write this in the form of NCR, or you may write this in the form of NCR. Okay? You may express this in any of these 3 forms. I have taken this form. This is for the coefficient of the binomial expansion terms. And a, the first term of this binomial expression, is getting raised to the power of n minus r. And the second term b of the binomial expression is getting raised to the power of r. Okay? And NCR is the binomial coefficient of a to the power of n minus r times b to the power of r. Okay? What is NCR? NCR is equal to n factorial over r factorial times n minus r factorial. Now you see we are having these factorial notations. These factorials and the factorial notation. Now you understand why did I start with the factorial notation when I had started with this chapter, the binomial theorem. The first thing that we had learnt when we had started the binomial theorem chapter was the factorial notation and the factorials. This is where you are having the application of the factorial notation and the factorials. Okay? And NCR, C stands for combination. So, NCR is needed while you solve questions from combination. But right now, we are interested in the binomial theorem questions. Okay? So, NCR is equal to n factorial over r factorial times n minus r factorial. What does this mean? Let us see. Let us take, say, 5c2 factorial as 5c2. So, 5c2 can be written as in this manner or in this manner or in this manner or in this form. Okay? But what is it equal to? Over here, the upper one is n. So, n is equal to 5 and the lower one is r. So, r is equal to 2. Okay. So, 5c2, what is that equal to? N factorial is in the numerator. So, it is 5 factorial over r factorial. So, 2 factorial times, there is the implied multiplication sign in between, n minus r factorial, that is 5 minus 2, 3, that is 3 factorial. Okay. And I'll be showing you how to get this value using the calculator, TI-Nspire calculator. But in case this is a paper 1 or non-calculator question, then how do you get the answer? How do you get the number? Which number is equal to 5 factorial over 2 factorial times 3 factorial? And we have done the simplification questions involving factorial, so you should be knowing how to get the answer. So, 5 factorial can be written as, I'll be always expressing the largest factorial in terms of the larger number factorial in terms of the smaller number factorial. And 5 is the largest, so I will be expressing 5 factorial in terms of either 2 factorial or 3 factorial. Since 3 factorial comes first, so let us take 3 factorial. So, I am expressing the 5 factorial in terms of the 3 factorial. 5 factorial, 5 times 4 times 3 factorial. 5 factorial is equal to 5 times 4 times 3 factorial over, always we take the second largest number. If you are having 3 factorials, you express the larger factorial in terms of the second largest factorial, numbers factorial. Okay. So, 2 factorial times 3 factorial in the denominator, and these two will be getting cancelled, and 2 factorial is equal to 2, you know. So, this is 2, and in case, again I am saying, in case you are not familiar with this factorial notation, I would definitely be asking you to watch my video, the first video on factorial notation, to know about how to simplify the question, the expressions containing factorials. Okay. So, this is equal to 5 times 2 is equal to 10. You have to know how to get to the answer, get to the value of 5 factorial over 2 factorial times 3 factorial, because this may be a question which is from the non-calculator paper. In that case, you cannot use your calculator. Of course, the same thing can be obtained using the calculator. Now, I am showing you how to use the calculator to get to this value 10. Okay. You may write NCR, just NCR and 5, 2. Okay. 5, 2. Enter. You see, it is 10. or else you can click on this menu button, come to the probability, come to combinations. Again, this time you don't have to type the NCR thing. It is giving NCR, and now you have to give 5, 2, and you will be getting the same thing, 10. So we have seen how to just type NCR and within the parenthesis you give 5, 2, you will be getting the answer 10. Or else you can click on the menu button, then to probability, then to combination, you will be getting this NCR function, and within the parenthesis you give 5, 2, input 5, 2, you will be coming to the same answer 10. And also we have seen how to come to this 10 just manually doing the simplification. Okay. So this gives us the different coefficients of the different terms present in the binomial expansion. Okay. We will be learning about this in details. We will be solving many questions on binomial theorem. So we will be learning about these in details. Okay. So the general term, this sigma notation gives all the n plus 1 terms. But there will be questions in which you will be interested in getting only a single term. Like in our previous video, we have seen there was a question, find the coefficient of the term which contains a to the power of 3 and b to the power of 3. But since we were using the Pascal's triangles to get the coefficients, we had to get all the coefficients, at least the previous ones, to come to the coefficient which will be having a to the power of 3 and b to the power of 3. Actually, we get all the terms because just by getting the coefficients, we may not be knowing which one will be the coefficient for a to the power of 3 and b to the power of 3. So we get the entire row in the case of Pascal's triangle. But this is the beauty of having the binomial theorem expressed in the sigma notation form, and when the binomial theorem is or binomial expansion is expressed in the sigma notation form, the general term is given in this form because the coefficient now is given by NCR, and we do not use the Pascal's triangle. We do not have to depend on the Pascal's triangle for the coefficients. Okay. Therefore, we can get a single term. That is the advantage of using this method. Okay. And we will be using this method. The general term in the binomial expansion of a to plus b to the power of n is NCR a to the power of n minus r times b to the power of r. Okay. Now let us start with some questions on binomial theorem. But before that, let us know a little more about NCR. Okay. The first question says, use technology to find the unknown value. It has two subparts. Subpart A says 14CR equal to 2002. So you have to find the value of R. Let us start with our answer. (14CR equal to 2002), we have to use the calculator. For that, we go to menu, algebra, numerical solve, and we come to NCR. NCR, and it is 14CR. So 14, comma R equal to 2002, and then comma and declaration of the variable R. Okay. Close the parenthesis. Enter. R equal to 5. In case you are doubtful, let us see. I am typing NCR and parenthesis 14, 5. See, you get the value as 2002. Therefore, the value of R is equal to 5. Okay. So, for the first subpart, so R is equal to 5. Okay. For the subpart B, NC5 is equal to 792. We have to find the value of N. NC5 equal to 792. Same technique. We go to menu, then come to algebra, come to this, and NCR, comma, N, comma, 5, parenthesis closed, equal to 792. Now we have to declare the variable, it is N. Okay. Enter. 12. Again, I am checking whether we have got the correct answer or not. NCR 12, 5, 792. See? So, the N value is equal to 12. N is equal to 12. Okay. So, this was our answer to the subpart A, and this is our answer for the subpart B. The next question. Write down the first 3 and the last 2. First 3 and the last 2 terms of the binomial expansion 3x plus 2 over x to the power of 15. Do not simplify the answer. This is the beauty of using the sigma notation and NCR for the getting the coefficients. Okay, because you can just select specific terms. So, let's start with our answer. The binomial theorem was A plus B whole raised to the power of n was equal to sigma r equal to n, 0 to n, and NCR A raised to the power of n minus r, B raised to the power of r. Obviously, there are these implied multiplication signs in between. Okay. So, the starting value of r is equal to 0. They are asking for the first 3 terms. So, r value will be 0, 1 and 2. Okay. We substitute the values of r as 0, 1 and 2. Okay. But before that, let me write the expression given 3x plus 2 over x to the power of 15. So, n in this case is equal to 15. N is equal to 15. What is A? A is equal to 3x. B is equal to 2 over x. Okay. So, this will be equal to sigma r is equal to 0 to n. N is 15. NCR, that is 15 CR. A is 3x. So, 3x raised to the power of n minus r, that is 15 minus r, and b is 2 over x. So it is 2 over x to the power of r. Okay. Now we will be taking the first three values of r, that is r equal to 0, r equal to 1 and r equal to 2 for the first three terms. When r is equal to 0, what happens to this part? It will be 15c0 3x times 3x to the power of 15 minus 0 times 2 over x to the power of r, that is 0. And let me show you what is 15c0. It is 15 factorial. You can use the calculator as well. 15 factorial times, over 0 factorial times 15 minus 0 whole factorial, that is 15 factorial. Okay. Let me write 15 minus 0. So 15 minus 0 factorial times 3x to the power of 15 and 2 over x to the power of 0 is 1. Now 15 factorial in the numerator, 15 factorial in the denominator, and 0 factorial is 1. Therefore, this is equal to 1 times 3x to the power of 15, that is 3x to the power of 15. They have not asked us to simplify, so I am not simplifying. I am not getting the numerical value of 3 raised to the power of 15. I am keeping it over here, and I have started from this first term as in this form. Okay. So if they want, they can take this, and this is slightly more simplified but not totally simplified. Okay. So coming to the second term, it will be the same, but r value will be equal to 1 this time. So it is 15c1 and 3x to the power of 15 minus 1 times 2 over x to the power of 1, because to the power of r is having a value of 1. And what is 15c1? It is 15 factorial over 1 factorial times 15 minus 1 factorial, that is 14 factorial. Okay. Times 3x to the power of 14 times 2 over x to the power of 1. This is 15 factorial and this is 14 factorial and this is 15 factorial. So 15 is the larger number, so I can write 15 factorial in form of 15 times 14 factorial. So that 14 factorial of the numerator and 14 factorial of the denominator will be getting cancelled, and we will be having the answer as only 15 from this part. Okay, 15 and times 3x to the power of 14 and 2 over x to the power of 1. I am not writing, just 2 over x. Okay, so this is the second term. And third term will be having the value of r as 2. So now you just notice one thing. For the first term, the r value is equal to 0. That is, the value of r is 1 less than the term number. You have to remember this. R value is always 1 less than the term number. When the it is the first term, term number is 1, r value is 0. When it is the second term, term number is 2, r value is 1. When the term number is 3, that is the third term, r value will be equal to 2. This is very important. You have to remember this. Okay. 15c2 times 3x raised to the power of n minus r. That is 15 minus 2. And 2 over x raised to the power of r, which is equal to 2 over x raised to the power of 2, is equal to 15 factorial over 2 factorial. Now this one I won't be simplifying because they have asked us not to simplify. The previous two were very easy. That's why I had given them, and okay, I'll be giving you the rule as well, but after I complete this entirely. Okay. 15 factorial over 2 factorial times n minus r factorial. That is 15 minus 2, which is 13 factorial. I am writing 13 factorial too. Okay. So 15 factorial over 2 factorial times 13 factorial times 3x to the power of 13 times 2 over x to the power of 2. Okay. They did not ask us to simplify, so we leave it as it is. These are the first three terms. Let me just write, okay, let me take another color. So this is the first term. This is the second term. And this is the third term. Okay, and they have asked for the last two terms as well. See, the last two terms of the binomial expansion. So we have given them the first three terms. Now we come to the last two terms. So, for the last two terms, what is the last value of r? What is the final value of r? R starting value is 0 and the final value is n. So, for the last term, r will be having a value of n. Therefore, what will be the value of r for the second last term? It will be n minus 1, obviously. Okay. Because r's value is increasing in steps of 1. Its starting value is 0, then 1, 2, 3, 4, it continues up to n. Therefore, the last term's r value will be equal to n. Hence, the second last term's r value will be equal to n minus 1. Okay. So, now we come again to this part. We come to second last term. First of all, and then we move on to the last term. So, for second last term, the r value is equal to n minus 1 times 3x to the power of n minus 1. And now I can write, first of all, I have shown that how is it happening, and now I just erase, and in place of n, I write 15. R's value for the second last term will be 15 minus 1, and this is n minus 1, that is 15 minus 1. Okay, because I am showing you for the first time, I am writing it in this form. Okay, and then it is 2 over x to the power of r, which is 15 minus 1. Now I can write this as 14. Straight away I am writing 14. Okay. So this is equal to 15C14 and 3x to the power of 15 minus 1 is 14. 15 minus 14 is 1. Okay. And 2 over x to the power of 14. Okay. Now let me show you what is the value. You may keep it in this form, no harm. But let me show you what is the value of 15C14. 15C14, if we just simplify this, it will be 15 factorial over 14 factorial times 15 minus 14, that is 1 factorial. And 15 factorial is 15 times 14 factorial. So 14 factorial of the numerator and the 14 factorial of the denominator will be getting cancelled. So you will be having only 15. Okay, that is what I had wanted to show you. This 15C14 will be equal to 15. Okay, times 3x times 2 over x to the power of 14. Coming to the last term, it is 15C15. R is equal to 15 or R is equal to n is equal to 15, so it is 15C15 times 3x to the power of 15 minus 15 times 2 over x to the power of r, which is equal to 15. Okay. And what is 15C15? Let us check. It is 15 factorial over 15 factorial again, and 15 minus 15, that is 0 factorial. And these two will be getting cancelled, and 0 factorial is a 1. So this is equal to this times 3x to the power of 15 minus 15 is 0. Anything raised to the power of 0 is 1, and 2 over x to the power of 15. So this is getting multiplied by 2 over x to the power of 15. And this part is 1, so this is in fact equal to 2 over x to the power of 15. Okay. So now let me write this to be the second last and this to be the last term. So this is the second last. And this is the last term. Okay. Now coming to the first term, that is 15C0, you see 15C0 was, this part was equal to 1. Okay. So that is how we had come to only 3x raised to the power of 15. And see the last term, 15C15. This is also equal to 1. And this is true for every value of n. You can remember this, NC0 is equal to NCn is equal to 1. Okay. Whatever may be the value of n, NC0 equal to NCn is equal to 1. And what about the first term? Sorry, it is not the first term, it is the second term. Second term, it is 15C1. 15C1, this part was equal to 15. And what is the second last term? It is 15C14, which is equal to 15. And this is also true for every value of n. So this is one relation, NC0 equal to NCn equal to 1. If you have a question from the calculator paper, you can use the calculator, so you won't be needing these properties. But in case you have a question from the non-calculator paper and you have to get the different terms, different coefficients, if you remember these properties, it may save you some time. So the other property that I may give you is NC1 is equal to NCn minus 1 equal to n. NC0 equal to NCn equal to 1. Hence, the first term's coefficient and the last term's coefficient will always be equal to 1. And NC1 equal to NCn minus 1 equal to n. Therefore, the second term's coefficient and the second last term's coefficient will always be equal to n. Okay? So, students, this brings us to the end of this session. We will be solving many more questions on the topic binomial theorem in our future sessions. Thank you for watching this video till the end. We meet again very soon. So till then, bye.